Greetings. My name is Clivin Geju, registration number 19BCE1480, a student of BIT Chennai campus, and this video is for the Machine Learning course Digital Assignment 1. What is machine learning? Machine learning is a branch of artificial intelligence and computer science which focuses on the use of data and algorithms to imitate the way that humans learn, gradually improving the accuracy. Now, in this video, I will be showing a simulation of one of the concepts in machine learning known as polynomial regression. And polynomial regression falls under the supervised learning. Machine learning has a total of three paradigms: supervised learning, unsupervised learning, and reinforcement learning. Supervised learning uses a training set to teach models to yield the desired output. This training dataset includes inputs and correct outputs, which allow the model to learn over time. The algorithm measures its accuracy through the loss function, adjusting until the error has been sufficiently minimized. Supervised learning can be classified into two types, classification and regression. So now, what is regression? Regression is used to understand the relationship between dependent and independent variables. It is commonly used to make projections such as for sales revenue for any given business. Some of the popular types of regression out there that is well known is linear regression, polynomial regression, and logistic regression. So in this video, I will be showing a simulation of polynomial regression using the software known as KNIME analytics platform. So let's get to see that now. So as you can see in this screen, I have the platform KNIME analytics platform. It can be used to practice several machine learning concepts. You can do from simple classification, you can do regression, you can do SVT, random forest, and all that. You can do it under analytics. Under mining, you have all of this. Under statistics, you have all of this, and for distance calculation as well, you have all of this. So you can practice or simulate different ML concepts on that. So let's get to see what the data set that we'll be using here. So the data set that I'm using is known as the data banknote authentication data set. So let me just get that now. So yeah, the banknote dataset involves predicting whether a given banknote is authentic or not given a number of measures from a photograph. It's a binary classification problem, which means that the result is of two types: either it's authentic or it's not authentic. So there are about 3,372 observations with 4 input variables and 1 output variable. These are the names of the variables, the 4 input variables and the output variable. So in the output variable, you can see the value will be 0 if the banknote is authentic, and it will be 1 if the banknote is not authentic. So this is what it kind of looks like. This data set is saved as a CSV file, and I've used the CSV reader node to include the data set. So you can decide that here when you configure, you have to click on configure to decide it. So once you do that, you can decide where the file is. You get to see what the preview of the file is. So as you can see here, they're showing some alphabets under each variable. So let me explain that real quick. D here stands for decimal. As you can clearly notice, the data that you have been given for each row under these variables are decimals. And class, the data type for class data set variable is integer, because you have only two values, which is either 0 or 1. So once you decided what you want, what your data file, you can just click apply and OK and configure. After configuring, you get to see this file table here exactly as how I showed in the preview. Now after doing that, we can add some colors to it. So what I've done is that I've added a 0 color for blue, red color for 0 and blue color for 1. You can decide what color set you want. You can do custom, you can choose the fixed set, you can do all of that, and once you've decided what you're comfortable with, you can click apply and OK. After that, and you get to execute it. After executing, you get to see, you get to see the table with colors now. So for the value 0, you're given red colors, and for the value 1, you're given blue colors. So after doing that, now we need to split the data to train our model and test the model. So when you do that, here what I've configured is for a 70% 30% split. So if you want to change the value, you can change it here. You can do it to 75-25, or you can do 80 and 20. After you're comfortable with how you want to split your data, you can click apply, OK, and then execute it. After executing, you'll get to see your partitions. Like the first partition is 960, so you have for 0 and for 1, and the second partition you will have about 412 rows, so you get to have for 0 and for 1, so it's evenly distributed. And also here among the 412 rows, we have also again split it further for testing data and validation data. So again here when you see the configurations, I have done again for 70-30 split. If I want to change, I would have changed it to another value. Click apply and OK, and then execute. After executing, you can see the first partitions about 288. You can have zeros and ones like that, and the second partition as well also has zeros and ones. It's about 124 rows, so it's much smaller. After doing that, now we will need to have the model learn the data. So once for that, you have to decide what is your target column. So in our case, it will be class. Then you get to include what are the variables that will be considered for using to learn the model. So once you've decided, if there's something that you want to remove from here, you can exclude. You can shift it using these buttons. After once you're done adjusting, configuring, you can click apply and OK, and then execute. After executing, you get to see your regression model. It will show something like this. It will show your specs, the lower bound, upper bound, and all that, the flow variables, and then this will show the data with the training error. So here, since we're using trying to predict the value to be 0 or 1, so you get to see our results here. As you can notice, we're having some positive and negative values. So the data type has been D. So if I were to change this from decimal to integer, then you can probably get an approximate. It's showing if it's coming accurately or not, but we leave it as it is for now. And then it will show what's the prediction error. So what you saw first was the prediction value and the prediction error. So and then that's what this shows. And then also you get to see the coefficients and statistics properly here. So p-value, t-value that's been used under regression, that's under the regression concept. And then once you've learned the model now we need to train it. So we connect it, and then we use the testing data to connect here. And then once you predict, you get to configure and see it will be defaulted at whatever you have chosen here to be the target class, target variable. So once you do that, you configure, execute, and you get to see the predicted data. Since your zeros and ones is just showing close to that. Some of them are not accurate, some of them are accurate. And then I have put a scorer, so it shows a confusion matrix of, I guess, 100% accuracy. And this is the accuracy statistics that it shows that it's gotten everything right. So that's what this is how I've done the simulation using KNIME analytics platform for polynomial regression. Hope I have helped you understand how we could use this software to practice not just for polynomial regression or linear regression. You can also try along the same lines for different ML concepts as well, like naive Bayes or clustering, or neural network, decision trees. More or less the same approach of will be followed for all these nodes and stuff. If there's something that you want to change from one data type to another, you can search for it here and you can get it. So that is all that I have to show. in this video and the simulation and explaining the concept of polynomial regression. Hope I have been able to be fruitful in giving you some better understanding of all this. Thank you for listening.